1968 and has held many positions such as the project director and program director. His contributions are reported behind the development of booster liquid stages of geosynchronous satellite launch vehicle and the uprating of the Vikas engine. He is working as the Senior Vice President, Propulsion at Skyroot Aerospace, Hyderabad, and also as the Chief Academic Advisor at GiveMe5.ai. As one of the greatest rocket scientists to walk the face of the earth, he is truly India's gem, and his achievements are as many as canvases filled by Da Vinci. Now the stage is all yours, sir.
Thank you for your nice speech, introduction. Well, I think I started my, as you told, in 1968, I finished my engineering and joined in ISRO. Maybe Kalam himself was there for my interview for my selection committee. So I joined in ISRO. So from that onwards, I started with solid propellant and liquid propellant and the cryogenics towards the end of my career. More than 20 years I worked. Or now currently GSLV upper stage is cusp project. I worked as a project director and of course retired. Maybe still I thought I have spent a lot of money on rocketry with so I want to, because hydrogen is my favorite for using in rocket, liquid hydrogen. So liquid hydrogen boiling point is only 22 Kelvin. So you have to produce and you have to use it in rocketry. So that is the way I started towards the end of my career and I complete. And so that way I started. But today, maybe towards the end of my talk, I will give some of my thoughts. The history of rocket, if you see that, okay, many people, they will talk about, the Chinese first time, like our, Deepavali crackers, they started flying small arrows and other things. But if you see really the starting point, 1633, Kazan flight tested a 7-winged object, maybe a rocket. And this is the, painting which is available in there, in Istanbul. So it is a 60 kg payload or total weight of the rocket. So near Istanbul, he flight tested. This was the, as per record, this may be the first flying object, maybe other than the small ones by Chinese and Tipu and other things. So maybe the later in India, 1790s, 80s, Tipu started making, like small rockets. Even the British, they were too much worried. Even they were reported, they were all, afraid of these rocket launchers by the Tipu in Mysore. So this is also recorded very well and how it has been done. Maybe the gunpowder he has used and he has pushed the fireballs and other things to the enemies and he was trying to use it. But when we talk about moon landing and Mars and other things, even 120 years back, there was a movie in France, La Voyage dans la Lune, that is the trip to the moon. It was imagined by somebody, oh, we will go to the moon at that time itself. So this is one of the film, it is considered to be the imagination by an individual. One day we will go to the moon and land. But if you talk about the modern history of rocketry, maybe the Russians, Konstantin Sersky is the person who has imagined like a space suit or how we can go to the space and the capsule and how we have to sit inside with low gravity and kind of thing. Even to reach the space, he is the person who thought liquid fuels can be good and the staging of the rockets and kind of thing. And he is considered to be the father of rocketry. Of course, Goddard also in same time, he was there in US. And these are all the people, they started, his equations are still valid for the rocket science. And later the French people also, they were doing parallelly. 1916, the pre-air rocket, that is the first rocket, they put it on a small aircraft. It's like a small missile, you can call it, or it's a flying arrow. So they are filled with gunpowder or a black powder or whatever you call it. It's similar to our our small rockets, what we use in Diwali time, but slightly a bigger one. And he is the American Goddard, and he is the person in 1926. He developed the liquid rocket, a small one, and he has flight tested from there. So this is one of the very important milestone in rocketry, how the liquid rocket has been developed by our this one. And maybe 1933, first liquid rocket in Russia. I think I will be here to mention. Korolev is the person who is the man who built the first liquid rocket. And fortunately, I worked in Korolev Institute, very near to Moscow for 1 year. That is called, from there, I think in his name, the institute, like our Vikram Sarabhai Space Center, Korolev Space Center is there. There only I have worked for the cryogenic program. And he is the person who developed a lot of liquid systems for Russians. So in his name, he is very well established, and then he is the person to be considered a modern man. But parallelly, some people, that's why I'm interested, how a Spanish man, he has designed the first space suit. So you could see here, this is a pressurized, you see here a small nitrogen cylinder or a helium cylinder, which is pressurizing a person in the suit. So this is, I will call it, you could see the head, with visible glass and air and other things. So they all thought about in vacuum, when you are sitting there with the different environmental condition, the body should have the exact pressure and other things and movement of the blood and everything. So for that, the suits have been properly designed. So this is the first suit designed by Emilio, a Spanish man. So this is the one later by Russians and as well as the Americans. They have modified to their requirements, and slowly it has become the better suits have been evolved. So this is also one of the major milestones in history of rocketry. And the first European rocket is the EA-41. Initially, everyone uses like nitric acid or the fuel like UDMH. So they are also started, but it is little dangerous, but still they started with a small rocket. So this is also happening in France. So this is 1941 JETO, that is jet assistant takeoff. Generally, the enemy, suppose if there is a war, the enemy will destroy your runways. So if the runway is destroyed, your fighting aircraft can, there is no use for that. So without the runway, if you want to take off the aircrafts or the fighters, they will fix a small rocket on the belly of the aircraft. If you fire the rocket, it will fly. So why I have taken so much time is 1941, 1973 or 74. I think Kalam was the leader to develop a JETO, or we call it RATO, rocket assistant takeoff. So we made 100 rockets and tested in the ground. Finally, 6 rockets we have taken to Raebareli and fitted with HF-24. And we were about 10 people there. I was also one among them along with Kalam. So very interestingly, we stayed in the military campus, and next day it is supposed to be takeoff. We have to fix, and the previous day we fixed the rocket on the belly and everything is fine. Next day morning 9 o'clock or 9:30 it is supposed to be takeoff. So previous night in the mess, I normally talk a little more. So I said, I don't know who is the unfortunate pilot who is going to sit on the aircraft. After a few minutes, somebody tapped on my back and he said, I am the pilot. Tomorrow I'm going to sit. Then immediately I cried, no, my rocket is so good, nothing will happen. And he is all laughing. But the next day, you believe it or not, it was a very successful flight. That was the first success for Kalam also. So we all enjoyed the Proton Rocket, which we developed in 1973. Then after, this is a solid rocket. And maybe very interestingly, when we were talking about Russians and Americans and French, the modern rocket is developed by the Germans during the Second World War. So there is a V2 rocket. Of course, there is a V1, which is only like a drone without a pilot, which will fly an aircraft. But V2 is a missile. And you believe it or not, even 1942, they used liquid oxygen as the oxidizer and turpentine as the fuel. And you could see the center, the cross section of the top red one, and the propellant tanks, and bottom the engine. And Hitler, and there is a mundane big one, tunnel in a mountain. One end, all the raw materials will enter. Inside the tunnel, there will be factories and other things to build. The other end, the V2 rocket will come out. Such a nicely they have planned and they have executed. And Von Braun was there along with this team. Of course, after 1944, and when the war is over, and Hitler died, and all this, you could see there is Operation Paperclip. That means the Americans, they tried to gather all the engineers they worked on these projects. They want to take them back to US. So one of the person is the Von Braun. He was the man, leader for Apollo mission, and he only built the biggest rocket in US afterwards. So he has taken most of the American engineers to that. So same time, the Russians also, they try to capture as much as possible, nearly about 2,200 German specialists. But I have read in somewhere, most of the engineers have gone to US, and most of the technicians, they have gone to Russia. Very few, they have gone to France. And of course, later, you may be knowing today, PSLV and GSLV second stage is Vikas engine, liquid engine, which is developed by the French people. So I also initially, from 40 engineers from ISRO, we have gone and worked in the French European Ariane program, 1, 2, 3, you may be knowing first one. So I stayed there for 3 years. I have an opportunity to work with one of this 2,200. There are about 10 Germans, they were come to France. So Mr. Berger, he was the man who developed the Vikas engine today, Viking engine or Vikas engine. Viking is in France and Vikas in India. So I worked with him. So after all those, 20 engineers or 40 engineers, we have come back in 1982. Then we started the Vikas engine, and we successfully, developed and given to our PSLV second stage. It was working. So same time, 1952, the French people already started flying the Veronique. So, but 1957, these are all the family of R7 or SS6 Sapwood. It is a missile, intercontinental first missile they developed by the Russians. And they have a very good technology, specifically on semi-cryogenic. I think V2 also a semi-cryogenic, but there the fuel is not that good. Here, liquid oxygen and kerosene. Kerosene means it is not a direct kerosene. It is a derivative of kerosene, removing all the sulfur content and other things, and a slightly more kinetic, energy of the fuel. So they use both liquid oxygen and kerosene, which was the main propellant for most of the Russian rockets, especially. I will explain a little later. So this is the series of vehicles they started, maybe in Soyuz and Voskhod and Sputnik. All they used the standard RD-107. You could see. So in Okay, here why I am showing is okay, in 1957 itself, first USSR launched the Sputnik. Even whatever you've seen is the American news they have read on the day. So maybe immediately, because there was a race at that time in 1950s and 60s between the Russians and the Americans. So same year or next year, you could see the US launches the Explorer 1 and it also went. And they also developed the missiles like ICBM, like with Atlas B. So there are many vehicles like Redstone and Atlas and like that, Titan. And even though solid also, they have the Minuteman. And of course, Russians, they have a series of solid rockets also, like for the missiles. So this is a time they have gone to the space. Just it is without any man and other things. Then slowly they started the first human space flight. That is in 1961. I think Gagarin, I think even some of you are going to Moscow, you could see the Yuri Gagarin's biggest statue in Moscow itself. So I am lucky enough to work 1 year in this field I told you. And whatever you are seeing, the Vostok 1 capsule where Yuri Gagarin has been put. It is a small sphere. I don't know how he was pushed inside and he was sitting inside. If you think about it, it will be little difficult to imagine. He has been pushed inside and he has gone out of the earth, and he was the first man. And I could see the capsule, and still they are keeping it in the museum. So this is one of the very major milestone in the rocketry, the first human space. And immediately same year, and Americans also, they sent the Shepard, Alan Shepard. He was done by Redstone, and he also went and returned safely. And 63, I think, first lady, Valentina, has been flown by the Russians. Maybe Americans, they took even afterwards 10 years or 8 years only to send the lady to the space. So these are all the things. And a very important one I would like to mention here is the Proton Rocket, where I have worked, and they have converted the old runway of a airport, and they constructed a long, like a tunnel in Germany. They put a long length, and this Proton vehicle is assembled, a huge one. And it is having a 6 engines on. This is the only rocket which uses UDMH and N2O4. You could see the NTO plus UDMH, nitrogen tetroxide and UDMH. Now currently we are using in our Vikas engine, is the same fuel for L100, our space, our GSLV and PSLV. And this is in Russia, I said they use only semi-cryogenic, but this particular vehicle, they use N2O4 and UDMH. More than 1,000 flights. Why this particular engine flight is very important for them, Proton? The success rate is very high. Maybe out of 1,000, maybe very few might have failed. 1 or 2 are recently, one also has failed. Otherwise, the success rate is the highest one. Same time, 65, Diamond vehicle is flown by the French. And they also started working. Then later they have jointly started a program with UK and Germans and French and Italians. They have started, each person started developing one stage. But unfortunately, 13 flights they have done from Australia. All the 13 flights failed. Then they fought each other. Then they said no. Then in 1970, French people, they started a program called Ariane program. So Ariane is started, okay, but now I was telling the semi-cryo. They say why we require the semi-cryo is the specific impulse, because I was telling somewhere storable like N2O4 and UDMH. There is a little, we are, even though the ISRO also we are using, it is not environment friendly. Both N2O4 and UDMH is not good for health, but still it is a good fuel and oxidizer, so we are using it. So that's why the Russians from the beginning, they were using semi-cryo. Now currently ISRO also developing a 200-ton engine. Of course, it is on the way. I don't know when it will be coming, right? So good specific impulse and very high throttle range. That is also one of the things. Pollution free. That's what I normally go and tell everywhere. You have to switch over to semi-cryo propellant or full cryogenic, this one. So in semi-cryo, always the oxidizer is the liquid oxygen, because directly you use the oxygen. And fuel is the UDMH or kerosene or methanol or ethanol or propane. Of course, even Russians, they have UDMH also only one rocket and one stage. And kerosene is the one mainly it is used. And now you could see here, this is the RD-107. And there are four thrust chambers. And each one will develop 100 ton or 102 tons of thrust. So you will get almost like 500 tons of thrust in this booster. And this is the workhorse engine for them. And they might have flight tested maybe more than 1,000. You could see the RD-107. Very interestingly, the Russians, they have slightly different thinking, thought process in the propulsion side. Like 4 combustion chamber, but they have only 1 turbo pump. The feed system is only 1. You can see on the top of that. So 1 turbo pump and 4 combustion chamber, and the steering engine separate. They will not gimbal the engine. So they always, even some more bigger engines also they have done only in this process. And this is a very, very, very successful engine. And today also it is working well. And this is another semi-cryogenic engine is called RD-170. You are seeing 4 engines. Each engine can develop 200 tons of thrust. So 4 engines means 800 ton thrust. Very, very, even to think about it, it is very, very serious thing. These 4 engines have only 1 turbo pump. This is the first stage of Zenith. So they have put 2 such engines in the second stage and 1 engine in the third stage. That's all. So the development time and everything is very simple. Same engine, 4 engine on the first stage, 2 engine on the second stage, 1 engine on the third stage. So Zenith is finished. So Zenith is also a very successful rocket for the Russians. And you could see this is the RD-170. You could see the 4 engines with the turbo, 1 single turbo pump. So the thrust is nearly about 800 tons of thrust, 1 turbo pump with 4 combustion chamber. So this is also one of the 1966. Okay, soft landing of something happened, and by that also first one is by the Russians. That time there was a series of competition, and Reddy openly told we should launch a man, land a man on the moon. So parallelly, Russians also they are working a moon rocket, but unfortunately the moon rocket, 2 biggest rockets exploded on the ground by the time the Americans landed on the moon. So, okay, USSR, they have the Soyuz spacecraft, and Zonda 5 also, they sent 2 tortoise, and it has gone around and it has come back. And you could see the first man to reach and orbit the moon. First, they have done not landing. They have gone and go around the moon and they have come back. Actually, they used to tell, I don't know whether it is true or not. Von Braun was one day sitting on the barber shop and he was a little bit worried. So the barber asked, why you are so much worried? And he said, well, I am thinking of sending a person to go around and how to land and come back. So we are a little bit worried. So the person who was, the man who was doing this thing, he said, why not like a mother and child? You have one go around the earth, one can detach like a child and it can go on land. Then again, it can come back and attach into the mother ship and it can come back. So maybe I am not sure it is true or not, but still that is the way they have done. First, they have gone as a mothership alone. They have gone around the moon. And second time, and mother and child, and one has landed, and Armstrong has put the first leg on the moon, and yes, you could see the first one, 1969. Maybe that is the year I finished my engineering. By the time the Americans, they have landed on the moon. Of course, there are so many small things. How can you get an impression on the moon surface? There is no moisture at all. Then how we will get to the boot this thing? How could there is no wind? How the flag is flipping? Such questions are all raised at that time, but we are very sure they have landed later also, so there is no issue at all. So parallelly, the Europeans, as I said, Ariane 1. This is the Ariane 1. This is the program I worked for 3 years. This is the Viking engine that I said I worked with them. And it is a very interesting. This is also using UDMH and N2O4 and both propellants and turbopump fed and gas generator cycle, and the divergent and the combustion chamber is KC20W superalloy, which can withstand a very high temperature. So we all learned, we have come back, and I am also one of the engineer worked back in ISRO to build this engine for LPS or PSLV and later for GSLV. And later, I think we all switched over to cryo. Why cryo? So you might have studied in engineering or anywhere, specific impulse. When we call it, it is the 1 kg of propellant. If you burn, how much thrust it will give. That is the index for the combination of the propellant. So it is the proportional to the combustion temperature and inversely proportional to the molecular weight. So that is the way. If you use hydrogen, if you see the table, the atomic number is 1. The lowest density or lowest weight is the hydrogen. So if you use hydrogen, the molecular weight is so less, you will get the maximum specific impulse. So that's why you are to use. Then you may ask, okay, you use hydrogen. Why do you want to go to liquid hydrogen? Because that is so much low temperature, like 20 Kelvin or 22 Kelvin. To reach that temperature is very complex. Yes, if you are using gas, it will occupy 720 times of the volume of 1 drop of liquid, 720 the volume of that one. So so we have to cool the hydrogen to make it liquid, to store it on our rocket to take. Even if you make a liquid, the density of the liquid hydrogen is only 70 kg per meter cube compared to water is 1000 kg per meter cube. So still, in that case, hydrogen, even though it is a good fuel and many respect it is good, because of the density is less, it lacks little thing. So you could see here the space shuttle, and the biggest tank is the hydrogen tank, which is the what you are seeing, and the side is the solid rocket motor assistance. And similarly, Ariane 1, I said I was working 1, 2, 3, 4. All are same, except they added side some of the strap-ons and increased the payload. But as I said, N2O4 and UDMH, the Europeans, they said we should not work on this fuel. We have to go for green fuels. So Ariane 5 was developed with the liquid hydrogen and liquid oxygen with the 100-ton engine. So that is the one biggest. Now currently they are not using 1, 2, 3, 4, and they use only Ariane 5 using liquid oxygen and liquid hydrogen, and two strap-ons with the giant solid rocket like what we are having. And of course, our friends Chinese also not keeping quiet. They also started in 1970, like us, or even slightly later, but they have built more than 12. I think today they have mastered the technology of even they have the biggest vehicle. They have put the man around the earth already, and they have a lot of technologies. Even the recent one also you might have studied in many things. And most of the vehicles, what you are seeing on the right side, are the biggest vehicles today, and tomorrow what they are planning to do it for human beings. The Japanese currently, they got one Atlas, one of the vehicle, they got it from US, as a license. Then they started with that. And later, they switched over to full cryogenic. And whatever you are seeing, the H2 and H2A and the H2B, these are all the vehicles they use only liquid hydrogen and liquid oxygen. And they have also developed parallelly, and they have done. They are also not spending many vehicles. They are augmenting the loading like us. So that is the way they have also developed. Now, deep space in 1998, they started. Here, why I want to say is the propulsion slightly, they have changed for satellite and other things, for long voyages and other things. We require, long time burning. So we cannot expect only UDMHR N2O4 and other things. So ion thrusters are developed. So with that, I think deep space technology started, and they are planning to go to Mars and other places and other things. We also started. So the Russia launched Zarya module. So you may be knowing now we have space stations and you can go there. This is one of the module. Of course, I have seen very interestingly one of the ground module I have seen in Russian Space Center. Now later, the NASA and the Americans, they have now gone to privatization. So the SpaceX today is one of the biggest industry for space, and they have Raptor and Merlin and so many engines. And 2008 only they started, and today they are the king in the space program, and they are inviting. They have gone for a new fuel like LOX and methane or LNG. So they have selected this one. So why I am telling specifically, currently in Skyroot, where I am working, I also started with LOX and LNG. I have already conducted a 1000 Newton test, a cryogenic, full cryogenic engine, and fired for 20 seconds 2-3 months back in Nagpur. It went very well. Now 2000 Newton, I am planning to do it in another, maybe in June, July. And these are all the things. And in addition to that, currently there are private companies, even in New Zealand, they have an Electron Rocket, which is also similar to our Skyroot Vikram 1. And they have developed all, this is also semi-cryogenic with a number of engines with small thrust chamber and other things. And all the engines are 3D printed. Very interestingly, now the world is moving towards printing. The mechanical engineering, whatever we have learned earlier, is slowly switching over to 3D printing of the metals. So whichever metal you want, titanium or inconel, you can print it in whatever shape you want, the engine shape or anything. Now currently, whatever I am talking about, 1000 Newton and 2000 Newton for my program also, I have 3D printed my regeneratively cooled engines for that. Later, for interplanetary missions, I think a lot of people, they worked on nuclear propulsion. And both Americans and Russians, they have developed the nuclear engine. But due to safety reasons, and among all the countries, we should not launch any nuclear propulsion. In case if the lower stage malfunction, then the nuclear fuel may fall on the earth and it will be very dangerous to this thing. So they are not using. But they are trying to use the RTG, that is a radioisotope thermal generator. So you can generate a temperature by a low decaying of the material, and you will get nearly about 800, 900. You can know the Peltier effect. You can have 2 different temperatures. You can produce electricity. So with that, maybe the space lab and even to long voyages to power the ion thrusters and other things, they generate the power by this means. So this is now currently many people, they are successfully, they have developed this RTG. I think ISRO also working with now currently with our nuclear propulsion people. So this is the one. Then of course I have talked about the French, Russians and Americans and all those things. So towards the end, I thought I will show some of the Indian thing. I think Sarabhai is the man, he is the visionary. So he has told we must second to none in the application of advanced technology to real world. So I'm lucky enough to work with him initially for 2 or 3 years. I joined in 68. Of course, 70, he's 71, he passed away. So we could have only for 2 years, I could work with him. Many times he has come and appreciated our work and other things. And finally, our government is not like Russians or Americans to develop many rockets and many engines. So that is not requirement. So our requirement is only IRS and INSAT. IRS is low Earth. You put around, say, 500 kilometer orbit satellite, which will observe the Earth, maybe our border or our ocean or our cities and other things. So we require a big electronic eye to watch. So to put that, we require a rocket. That is the PSLV. And INSAT, so we have to put a satellite at 36,000 kilometers to have the synchronous way it has to rotate the speed of the Earth so that the satellite will be always above you. So the INSAT, that is the GSLV we developed. Till the GSLV developed, we were launching with the French people in French Guyana. Now currently, both our requirements are met. Only we are going for a bigger and payloads. So when I joined, I also started, with VSSC at that time. It was SSTC actually. Then later only after Saraba is this one, it was changed to VSSC. So we started with a sounding rocket. You could see RH 75, 100, 200, 300, RH 560. All are launched from near Trivandrum and later from Sriharikota. And now SLV3, of course, our Kalam was the project leader and we all worked. And ASLV was a failure for us and both the flights it failed. Then we switched over to PSLV and GSLV Mark III now currently. So all the three, PSLV, GSLV and GSLV Mark III is the workhorse for us and it is working very well. Now we are planning to, these are all the engines developed and where you are seeing the cryogenic pump fed, that is the engine I built first in ISRO. For that only I went to Russia and stayed there for 1 year and learned the technology and come back. The government is willing to give, kind enough to give 300 crore project. I was the first project director to develop the 75 kilonewton. This is the one now currently GSLV third stage, which is powering. This last one is the one which we got from French. There also I have worked. So this is the thing. Now currently we are working for, ISRO is working on manned missile and all of you know that. And already they have built the crew models and other things and testing and everything is going on. Maybe I think new chairman has already announced and they may not be there. Originally they planned 2021, but because of the corona and other things, 2 years, there was a small delay. They have one more interesting mission is the Aditya L1. They want to put a satellite in Langeron thing there. The pulling of the Earth and the moon will neutralize that point. If you put the satellite can absorb the Earth without any disturbance. So that one also they are planning to do it in another 1 year time. And there is another interesting thing they are doing it, a synthetic aperture radar. So it will go and flood like a fishnet, a bigger one, and then it can do all the work. So Mangalyaan 2, and they are also planning a flyable, reusable thing with rocket propulsion. Of course, for that only the semi-cryo 200-ton engine they are now developing. If once that 200-ton is developed, they can replace Mark III first stage with L100 with UDMH and N204. They can replace with this semi-cryogenic engine. In addition to that, ISRO they developed ion propulsion. So you could see the very interesting plasma. And when you see the plasma, because you might have studied the fourth state of matter is plasma, but when you see the plasma, it will be very nice. So this plasma thruster also worked in one of our satellites. And in future, the Vazimir for international flights, variable specific impulse macrodoplasma rocket. Maybe youngsters like you have to take a lot of interest and there are a lot of things to do in future. And as I said, the semi-cryogenic rocket in India is also now currently working. Still, it is, a lot of milestone not that they have started. So some of you are interested, that is in propulsion. This is the Basmir also. Now currently many people are working. And in Bangalore, in LPSC, they are also started doing pulsed plasma as well as xenon plasma. Both they are doing. This work also they just started. Maybe you youngsters, you can start. These are all just a glimpse of what happened for the last 400 years, how the rocketry has slowly. Maybe there are many other things, solid I didn't touch at all. There are many solid rockets and even hybrid rockets and all those things. And it is a very great pleasure to talk to you. And okay, this is fine. Thank you very much for listening and this one.
Thank you so much, sir. It was a very insightful session. Sir, it was very enriching and intense session. We have surely been inspired, and I'm sure the audience is going to, take home a lot of knowledge and analogies today. If anyone from the audience would like to have any queries, you can put it in the chat box.
So what is a future you see, sir, in propulsion industry? Hello, are you listening?
Yes, sir.
Yeah, now future is, well, I said LNG will play a major role. Why I said LNG? Now today the cost of the payload, if we want to put 1 kg of the payload in space, it may cost $10,000 or even $20,000. Why? Because liquid hydrogen is also costly, and solid rocket and everything is costlier. So the main interest is you have to develop very fast, you have to launch. At the same time, the cost should be very less. And today, if you take LNG per kilo is only about, say, 100 or 150 rupees or even less. But if you take hydrogen, it is more than 3,000 or 3,000, 4,000 rupees. So we want to develop every country, even SpaceX or Skyroot or ISRO. They want to develop, cheaper fuels and good performance. Actually, the LOX LNG is better than LOX RP1. RP1 is kerosene. So, in my opinion, future we are also thinking, ISRO also thinking to develop 100 to 150 ton LOX LNG for booster applications. And for upper stages, they are all now working. Many people, they are working on storing the cryogenic is little difficult. You know that because it's like a flask. So the cryogen 20 Kelvin, any heat comes immediately, it will become vapor. Then it will create a lot of issues. So how to even the space itself, whatever the vapor comes, again you cool it with the Stirling cycle or other cycles to remove the heat, and again you make it a liquid hydrogen or liquid oxygen, so that it can be used again and again in that place. So that is one way. Then we have not touched much, and people are working on solar. We take if you want to go for a long journey, like Mars or years it takes. So one is food. Second one is the propulsion, environment, the time management, all those things. So when you are talking about it long time, if you want to run, the solar propulsion is the best one. So how much we can take, and there are things now they have done. Fuel cell technology now they are trying to. Even Russians long back they started in their space lab, whatever lab what you are seeing. Most of the housekeeping is done by the fuel cell. You know very well fuel cell. hydrogen passes through the dry naphion. It's split into hydrogen atom, then hydrogen is, the electrons are taken as a load, as a power. So the fuel cell is the one. So two advantage. You split the water with solar power into oxygen and hydrogen. Use the hydrogen and oxygen once again in the fuel cell to make the electricity. So you could have, cycling of that one. So this is very important thing. And LNG may be the future, as you are asking for this one. I pursue, even though I love hydrogen very much, but I feel LNG maybe in future it will come.
So there is another interesting question what we have for you in the chat box, and that is, you had amazing experience, and that everyone is extremely happy to see and acknowledge today in this session. They're asking if you can share one life learning lesson with them. What was your one life learning lesson which has transformed you as a person what you are today?
Yeah, very interesting. I don't know, maybe if you go and ask in ISRO, who is the man who has exploded many rockets, without hesitation, they will tell my name. Maybe when I joined, say first time, they have given me a small tiled house and asked me to work on solid propulsion. So I mix with ammonium perchlorate with rubber or whatever fuel available and put it in a small rocket and load it. But whenever I remove it from the oven, a lot of blowholes and other things. So again, I, like a young man like I thought I'll put both sides a clamp and tighten it and put it in the oven. You believe it or not, luckily when I go out, within few seconds it exploded. So the first lesson I learned, what is energy? If you play just like that, it will show its own color. So maybe next time when Kalam was there in the SLV time, fourth stage, there was a big blowhole and I was trying to rectify it. At that time also there was a very big explosion. The whole building was shattered. So the failures, it gives me, a lot of strength to learn what happened, what is the mistake I did, how I can correct. I should not do the same mistake once again. So like that, I built. And in my career, 76 to 79, when I was there in France, so as I told, I had a very good exposure to the propulsion field. There also, I myself, I changed a lot. So I come back, I worked on liquid propulsion. Later, due to many reasons, they asked me to start the cryo program. I don't know at that time what is cryo, but I have gone to the middle management level. I got youngsters like you, maybe 12 or 14 engineers. I started. You believe it or not, again, I blasted many rockets. And especially when I started with liquid hydrogen and liquid oxygen. So I don't know. So later I understood the liquid hydrogen is like a Maharaja. It goes, it freezes everything. So who is the Maharani to control the Maharaja is helium. So like that, if you ask me one thing, and one of the very interesting thing in my last 40 years in ISRO is every day is interesting type. It is not a repetitive of what I was doing. Every day the engineers will bring new problems and we have to give solutions and working out. So it is an amazing experience to work with people like, Vikram Sarabhai or U.R. Rao and Kasturi Rangan and Dr. Muthanayagam, Kalam. I am one of the blessed person to work with such big people. So I could get some of their this thing also. So now currently you may ask, maybe I am now 76 or 77. Why I am working is whatever I know, I want to give it to my youngsters. So that is my interest. So now currently I am very much happy with young energetic engineers. And they have very good knowledge. And those days, there is no CFD analysis and FE analysis and kind of thing. Everything we used to do with the hand and other thing. Now, if I say something, next day, people bring with all those things. So I appreciate. I think every day is a good day and an interesting day for me. Thank you.
Thank you very much, Dr. Gnanagandhi. That was amazing, amazing session. There are various questions again, sir, coming on board with us, but time we will move ahead with the ceremony. And now it is time for vote of thanks, sir.
Thank you.
We are extremely heartfelt thanks, like our heart is completely filled with gratitude, sir, with your presence, a presence like you being there. It has actually enhanced the complete consortium to extremely another level. It means a lot, sir, for your kind presence. Thank you very much once again. And I will request my team to kindly share the certificate of like the memento of gratitude to Dr. V. Gnanagandhi for his kind and humble presence. And guys, please understand that he's such an amazing person with so down to earth. Even he has achieved so much in his life, and still he's so down to earth. He's readily talking with us whenever we are asking him to, okay, sir, can you please change your schedule for us? And he is more than happy to do that for us. Thank you once again, Dr. Gnanagandhi. It means a lot, and extremely happy with your presence. It has taken our exportium consortium to the next level. Thank you. Now, thank you, sir. Without thanking two eminent personalities, Dr. Rajeshwari Hegre and Dr. Susan Elias, we cannot move forward, because without their mentorship, we could not have reached here. And we could not have done so far, and you could not have been seeing us and on a big platform like this. So thank you, Dr. Rajeshwari and Dr. Susan, for your continuous guidance and help wherever we needed your help. I would love to extend my thanks to each and every collaborators who were so humble and so helpful throughout the planning and organizing of this particular international research consortium. Thank you, guys. Without you, it was never a possibility. And in the end, there are two people whom I would love to thank. One is our sponsors, Verigo Motors and EduChecked, and another one is the audience. Because this is what we are doing for you, to get that ignition inside you, get that spark inside you, and so that you can also become like a huge and amazing personality like what V. Gnanagandhi is. And now you will be our role model, sir. And we will be looking forward to you for more helps, more knowledgeable sessions, and amazing learnings. So thank you very much. Thank you, sir.
Thank you.
Also, guys, stay tuned with us, because the next session is coming by Dr. Prasad. He is the current director of NIT Calicut, and he will be briefing on how to engineer yourself. Amazing topic, amazing session coming up. So stay tuned with us.